Hey team, I'm Corey. How's it going? Thanks for joining me. I go by CoreyJA on the internet. You can find my blog at CoreyJA.com. And today we're going to do some Advent of Code puzzles. I am on day 5. I had started doing these at midnight, but it was a little too late for me to do these streams, so we're going to do them during the day now, or in the evening at the moment. So let's jump right into day 5 and get going. Day 5, if you give a seed a fertilizer. I think I need to turn this down just a touch so I can read this story nicely. Awesome. You take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more like a farm to you. A water source? Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Can you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived and we're having trouble making sense of it. The Almanac, your puzzle input, lists all the seeds that need to be planted. It also lists the type of soil to use with each kind of seed, what type of fertilizer to use with each type of soil, and what kind of water to use with each type of fertilizer, and so on. Each type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, soil 123 and fertilizer 123 aren't necessarily related to each other. And then we have some examples. So there are seeds, 79, 14, 55, and 13. The seed to soil map has these seed to soil map. Why are there 3 values in each of these maps? The almanac starts by listing which seeds need to be planted. The top ones, yep. The rest of the almanac contains a list of maps, which describe how to convert numbers from a source category into numbers in a destination category. That is, the section that starts with seed to soil map describes how to convert a seed number to a soil number, the destination. This lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the map describes entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. Consider again the example seed to soil map. The first line has a destination range start of 50, a source range start of 98, and a range length of 2. This means that the source range starts at 98 and contains 2 values, 98, 99, and the destination range is the same length but it starts at 50. So its values are 50 and 51. With this information, you know that seed number 98 corresponds to soil number 50, and that seed number 99 corresponds to soil number 51. The second line means that the source range starts at 50 and contains 48 values. This corresponds to a destination range starting at 52 and also containing 48 values. So seed 53 corresponds to soil number 55. Any source numbers that aren't mapped correspond to the same destination number. So seed number 10 corresponds to soil number 10. So the entire list of seed numbers and their corresponding soil numbers looks like this. They're all the same until you hit one of the ranges that's offset, and then you do those. And then that keeps going till the end. With this map, you can look up the soil number required for each initial seed map. So then you find the soil numbers. The gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. To do this, you'll need to convert each seed number through other categories until you find its corresponding location number. In this example, the corresponding types are seed 79, soil 81, fertilizer 81, water 81, light 74, temperature 78, humidity 78, location 82. And then you can follow these other ones, again, location 43, 86, and 35. So the lowest location number is 35. What is the lowest location number that corresponds to any of the initial seed numbers? Okay, wow. So this is going to be a fun parsing problem. And location is the bottom of our map here. So I wonder if it's fair just to say that each stage, like I don't know if I need the words really, right? I just know that you have to go through each of these. Just because the words here are going to be slightly annoying to capture, I think. I guess maybe not, right? Because if I'm just doing maps all the way down anyways, I don't know. We'll think about that. Yeah, okay, so let's just get started. We'll get started parsing these things out. We'll probably at least store the name of these maps, because I think I'm not going to hard code how many maps there are. That I think seems important to me. So yeah, we're doing Rust today. I actually don't know if I mentioned that, which is a little funny, but we're doing Rust as we've been doing for all of Advent of Code, and as I mostly have been doing on stream. Oh no, this is a long one. If you give a seed a fertilizer, if you give a seed a fertilizer, and the name is the same thing without, that doesn't start with 5, because that makes Cargo unhappy. Okay, so now we have to add it to our workspace with all of the other crates. Perfect, and now we can go into it, cargo run. This will just be hello world, because that's what the default is. But now we have a place to go. So let's get started with copying down our sample input. New file, sample.input. Add the sample input. Let sample input. Sample part 1 answer. Debug. I thought Copilot was just going to do it for me. There we go. Part 1 function doesn't exist. Well, how about we generate it? It's going to go to a U32, U64. I don't know. I don't think it matters. I think all these numbers are going to be pretty small. We'll do 32. Okay, so we have our input, and so what kind of structure do we want to parse into? So we know the seeds. That's kind of the easiest part here. And then, so like maybe we'll just be a little boring for naming at the moment because I don't know what else to call this. And we have an input that has seeds, and this is a vec of U32s. And so if I hard coded all of these, what I kind of could do is like type seed. Like I could make a struct for seed and be really specific about the types, but I think I want to do the maps more dynamically, and not be worried about the names as much. So I think we're gonna do like maps basically, and this is gonna be a vec of something, and then I think I want like another struct probably for a map entry, and it has the 3 things that were defined right here. No, this one. Destination range start. So destination range start has the source range start, and it has the range length. And I think I'm actually just gonna have a struct for each map too that has a name and then our entries. And then this is a vec of map. Cool, so now we have the structs that I want to parse into. And so now we just need to do that. So let's start with this. We'll do impl input. We want a function called parse that takes in a string or a reference to a string, and it's going to return a self. I think we'll just unwrap errors at the moment if we have any. I think it's just fine. Wow, let's just see what Copilot wants to do here. Wow, Copilot just wants to write the entire thing. I see some characters that we don't have here, so I'm just gonna call that a failed experiment, which is pretty fair. I would have been very surprised if it got it right, and I don't like how it's writing this anyways. So let sections equals input dot split on double new line. I like that because I wanted to split, yeah, on these empty new lines. And that'll split everything into sections. And actually, I don't want to collect that though. I want to leave this as an iterator so that I can do let seeds equals, this is going to be mutable sections because I need to do sections.next. This is going to pull the first thing off of it, which is going to be the seeds like portion, and then the map sections equals sections.collect. Now this can be a vector. Actually, we don't need to collect this. We can just map it, and for each section we can do, so a section is a map, so map parse s collect to a vec. Nice, I like that. Thank you, Copilot. Field expressions can't have generics. I don't think you understand what's happening here, probably because parse doesn't exist. And actually this is just maps, really. Field expressions can't, oh yeah, that's fair, field expressions. I needed to call the function. Okay, so now map. The first thing is let I like calling this input, just cleaning some stuff up. So actually I have, the first line is like the name, and then the next are these things. So I think we're going to do the same thing actually. Let mutable lines equals input.lines. Let name line equals input.next.unwrap. Let entries equals lines.map. Parse the entry, collect it into a vec. Perfect. And then I want to do let name line split equals split it on a space. Actually, no, let's just do name. Let's split it on a space, then do next unwrap, because we only want the first thing. Oh, and let's turn it into a string. That's a good call. Let's generate this method. Yeah, I like filling it with to do at the moment, just because I wanted to finish having this compile, which is name and entries, which I think I already have named right, so they can just be sent like that. Love it. And then we have to parse our map entry, but that's actually going to be pretty easy, I think, because it's just these three sections. So let nums equals line dot split. And let's not do split space. Let's do split on white space. I just like it better. I don't really think it matters here at all. And that's the numbers. So then self. Yeah, there we go. Perfect. I guess I maybe wanted to map these. I like that better. We can just say that we want a vec of U32s here. Oh, vec of U32s, not just 32s. And then these don't need to be parsed anymore. They're just already U32s because we parsed them in the map. Love that. And then we parsed everything. Oh no, well, perfect. So seeds here is I have to actually parse this out. So can I just do like seeds dot remove prefix? Isn't there like a prefix? Well, maybe I need to make this mutable though. Dot remove rust remove prefix. I thought that was a method on stripped prefix. That's why I'm not finding it. Stripped prefix of, yep, I like that. It was right. Copilot had it. Seeds. Dot unwrap. Sure. So actually, what does stripped prefix do? Is it returns a string slice with the prefix removed. Okay, so yeah, I want let seeds equal that. That doesn't need to be mutable. And then let seeds equal seeds dot split on white space dot map parse unwrap collect back. Perfect. Awesome. And so let input is parsed it, and then like for now let's just debug out our input and still do a to do here so that it can compile. I want to do reference to input, but that's not the error. The error is that input doesn't implement debug right now. But we can just drive debug. We're just gonna have to do that on all of the structs that we made, but that's totally fine. Woohoo! Okay, and now I should be able to run our main. And it definitely was supposed to panic because we had it to do, but looks like everything parsed nicely. Woohoo! Awesome. And actually, are they in order? I think they are. I guess I should just check to make sure. Seed to soil, soil to fertilizer, fertilizer to water, water to light, light to temperature, temperature to humidity, humidity to location. Yep, they're all in order. Okay, so for every, so I want to do, I guess I could have a method on input that's like mapped value. Yeah, let's do that. So function mapped value is going to be a seed. Yep. This type signature is right. This is completely wrong. Okay, so let's just make seed mutable there. And so we start with a seed, and then we want to go through the maps. So for a map in self.maps, so in the first map, now we have to look in the entries. So map dot entries dot find. We want to find one that where the value's in range. So there's an entry where for the entry in range for the seed. Yep, we're asking if the seed's in range. And I guess let's make this be is in range. Okay, so we find let entry equals that. Actually, so I don't think I want it to be is in range. I really want it to just be converted. Like I want to just do the mapping. So for the entry dot map the seed, I could just write the method map, or is that going to be confusing? Let's call it translate. Is there a find map method? I hope so. Oh, I also need an iter here. That's what all of this is mad at. And then I also just need to add this to do to make that. There we go. Okay. Yeah, awesome. So translate doesn't exist, but let's so entry here would be an option of an entry, a map entry. Oh wait, no, translating it. An option of a U32. So then seed equals entry dot unwrap or seed. Either you translated it or you kept your value, and then you keep going until there are no more maps and you just return that thing. So now all I need to do is write this translate method for one map entry. So let's see. So we need to see if it's in range. So if seed is greater than source range start and seed is less than or equal to less than, not equal to. Seed is, yeah, I think I want less than. Offset is seed minus this. Wow, Copilot nailed that. That's exactly what I want. So then what's the top? Oh, I have mapped value. Okay, so we're not done yet. I got a little ahead of ourselves. So function, actually, this is just part one. So let's just write that in part one. So we want to do input dot seeds dot iter dot min by key returns an element that gives the minimum value from the specified function. If several elements are equally minimal, the first element. Yeah, okay. So min by, what's the difference? Wait, what's min by versus min by key? Min by, oh, it's a compare function versus key. I want key. Okay. There we go. Iter, so the minimum seed, and it's the seed I want, right? By the location. Yeah. Okay. So seed input dot mapped value seed. There we go. Unwrap. Found a reference to it. Luckily, it's a U32, so we can just deref it, and that might be good. Ooh, let's do some clippies. I can not do the closure and just call map directly there. That was nice. Oh, this is gonna actually probably. Oh, it doesn't tell me to make it a split white space. I thought it did in a different case. Interesting. Could just delete it. But I kind of like it, so we're gonna leave it. Okay, cool. Run. 13. Was that the right answer? I think so, though. Wait, the lowest location. What is the lowest location number? Oh, they just want location number. Okay. I had that wrong. So this is just map. So one deref, not two derefs. Okay. Map dot min unwrap. Cargo run. We'll do it in the terminal this time. 35. 35. Perfect. Get my puzzle input. New file. My dot input. Moment of truth. Let's go up to my main and do let my input, my part one answer, debug my part one answer. Uh-oh. Attempt to add with overflow. Okay, awesome. Is this gonna be one where I need to change something up here? Substitute U32 for U64 globally. Try just using bigger numbers. I think bigger numbers were fine. Yeah, those are just some big numbers. Wow. Awesome. Okay, so there is part one. Day 5, part 1. Not part 2 yet. That's up next. Okay, continue to part 2. Everyone will starve if you only plant such a small number of seeds. Rereading the almanac, it looks like the seeds line actually describes ranges of seed numbers. The values of the initial seeds line come in pairs. Within each pair, the first value is the start of the range, and the second value is the length of the range. So in the first line of the example above, seeds, this line corresponds to 2 ranges of seeds to be planted in the garden. The first range starts with seeds 79 and counts 14 values. The second range starts with 55 and counts 13 values. Now, rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers. In the above example, the lowest location number can be obtained from seed number 82, which corresponds to location 64 at the end. So the lowest location number is 64. Consider all of the initial seed numbers listed in the ranges on the first line of the almanac. What is the lowest number that corresponds to any of the initial seed numbers? Okay, so now what we need to do is make our seeds different. And I think we're actually not going to use the name here, so now we can remove it. Now it's fine just to remove the name. Cool. So what we need to do though is change how the seeds are parsed. And I think we're gonna have a little bit of fun with generics real quick for that. So we're gonna do struct part1 seeds. It's just a vec of seeds. And we're gonna make a trait called seeds that has two things. Yep, it has a function parse that parses one, and it has a function seeds that returns a vec of them. Vec could make an iterator, not a vec. It's fine. We'll make it a full vector. It's okay, I think. And then so we will impl seeds for part1 seeds. And yeah, that works for me. That's the exact parse we need, and seeds here just clones it. Love that. Okay. So now what we want to do is, instead of seeds here being this, we're going to make our input generic on the type of seeds. Seed type maybe is what I want to call this. And seeds is a seed type. And I want to make sure that seed type implements seed. A little bit of a back and forth there, but I think the naming's okay. And then I'm gonna have to throw this generic argument through a little bit, but I actually gotta run to the bathroom real quick, team, so I will be back in like 3 minutes. Sorry about that. Hey team, sorry about that. I am back, and let's jump right into it. So we made our struct generic over the seeds type. And so now we just want to do impl for, well, I think we'll call it seed type again. I like naming these type parameters pretty specifically. So then this is for any seed type. And then, where it's seeds, yeah. Wrong place. I think we put it there. For any seed type that implements seeds, and then really what we want to do here is just seeds equals seed type parse. Get rid of all that other stuff. There we go. And then when we go to use this down in part 1, we can say now we have an input of part 1 seeds. Input with the type of part 1 seeds. We want to parse it. And then we can just call the method seeds here. No method. Oh, it's seeds.seeds. Because the seeds is the type that implements the seeds method. So not the greatest, but it'll work. And then cargo run, and that gives us the same answer that we got before. Awesome. That wasn't supposed to change it, and it doesn't. Awesome. Perfect. So that was just a refactor to make part 2 go nice and smooth for us. So let's make a commit. Refactor to use some or one specific types. And so now let's do the struct for part 2. Yeah. Just reorder this a little bit. Okay, perfect. So struct part 2 seeds. So no. So struct, we have a seed entry, which is a seed start, and a count, like how many of them to do. Awesome. Part 2 seeds is never constructed. Yeah, that's okay. So this is really entries, is a vec of seed entries. Love it. Impl part 2 seeds. Oh wait, no, it's impl seeds because we have a trait this time for part 2 seeds. And then we're actually gonna let Rust Analyzer fill in the bodies, not the bodies, but fill in the method structures for us, the signatures. Okay, so now we need to parse our part 2 seeds, and the first thing that we do want to do is do the prefix stripping So let's just do that. So then now we have, we can get to this, or actually we got rid of the white space. So we have the numbers, but now we need to parse them in pairs. So let's actually do from here, let's split on white space and collect to a vec. Because now I want to go in pairs. I think I'm just gonna do this a little manually. So for I in wait, what's step by? Step by 2. What does step by do? Iterator.step by 2. It goes 0, 2, 4. Sure, that'll work for me. Yeah, that'll definitely work for me. Thank you, Copilot. Oh yeah, okay. So this is actually better expressed as a map, I think. So let's do that. Let's do this dot map. And then, okay, sure. We'll just take all of Copilot's suggestion for it. Love it. Collect that to a vec. This is let entries. Love it. Self entries. Perfect. So now we can parse our part 2 seeds, and now we just need a vector. And so I think for that, I'm actually going to start with doing an impl for seed entry where it's seeds. Wow. Okay, Copilot. Is that what I wanted? From seed start to seed start plus count, collect that to a vec. It's exactly what I wanted. So then what I wanted to do here is self dot entries dot iter. We want to iterate over them. Dot flat map to call seeds. Yep. I cannot tell it if I leave off the collect, it knows it's a vec because that's what the method's supposed to return. And that's about all I should need to do. I think I want to add some debugs to these structs as well. And I think we try it out. Part 2 is actually basically exactly the same as part 1, except for this is just part 2 seeds. And that's part 2, which really means I could make this function generic. Yeah, let's do it. Why not? So let's call this solve. But it takes in a seed type, which implements seeds, of course. And so this then is seed type. And then I guess I'll have a part 1. I like having part 1 is solve with part 1 seeds. And then we can have the same thing for part 2, which is solve with part 2 seeds. Nice. So then this will be a part 1 still. Part 1. And so let's do let sample answer part 2, debug sample answer part 2, cargo run 46. 46. Okay. Let my answer part 2, my part 2 answer. Ooh, and this is where we are running into an optimization problem. If we do these one by one, it's gonna take too long. I kind of was wondering if that was going to be the case here. But let's think about this, right? So we want the lowest location number. And because of how these seed things work, like if we start at 79 here, 80 is then going to be a higher seed. And the only way that 80 is lower, oh, because the next thing could start at 80 and assign it to a low number. So I can't get away with not checking any, and I can't just check the start and the end because it could just be in the middle that it goes down to a low number. So I do need to maybe check all of them. Yep, but I assume I just can't, and I guess the other thing that I can do here is I can run this in release mode, which is going to take a sec to compile. Oh, no dependencies. It's really quick. But I can't imagine this is actually going to solve it much faster. I could bring in something to do this in parallel, so I could like use all my cores to try to find this, and that could be potentially interesting. But there's definitely a way to optimize this in the problem space, because there always is with these advent of code ones. And so I'm trying to think of what it's gonna be. It's something with these ranges, right? So, because you only need to check the lowest thing, except that ranges can map you to completely different places. And it could be in the middle too. But if you know contiguous, okay. Plus .excalidraw. Excalidraw is a nice drawing app that I like. And so here's what I'm thinking. If this is a seed, like a seed entry, I think I called it, right? And then there's some maps like that go in here, and we're just gonna call these maps. They're at whatever level, and like these things could be repeated at multiple levels. But if you have maps, and maybe you have one that then goes off the edge like that or something. Ah, no. Group. Okay, so we have our maps. Really the ranges now that I need to care about, I can draw them in like blue, are here to here, and then there's here to here, so then that means there's here to there, there to there, there to there. Basically, I'm just doing all of the breaking it apart every time there's a map at the next level. But then, the only ones I actually care about there then are going to be like this one. I only need the lowest of each of these. So I really need to just check the cases where we switch from one map to another. So either unmapped to mapped. We don't need to keep going for all of those. So I think that means I want to restructure I'm gonna need to restructure the code a little bit, because for each seed entry, we're gonna need to. So that would only work at the top level, right? Where I have a range of seeds. That would still help a lot, right? Because we're changing it to this many. Wait, does that work with maps to the next layer down? No, because what if because one thing that I'm doing then is I'm ignoring this circle right here, right? And like on purpose. But what if there's another map at a different layer that starts right there? So do I need to check every... I need to go... Do I need to go backwards from location? Like, I want to find the entry points for each map entry all the way up. Ooh, I want to find the seed for each map entry all the way up. Here we go. I like this. Here's the thought. If we draw our map, so the blue is the old idea. Blue is not good. But we can draw some more of these, right? And they don't, oops, whoa. They don't have to line up with these ones. They can kind of just be anywhere. We can even have some green ones, right? Oh, sure, turn that one green. That's not what I wanted, but it's okay. There we go. We can even have some green ones. Maybe they're bigger, sure, it doesn't really matter. Okay, so then the points that we care about are gonna be these ones. There's one here. There's one where that map starts. We'll say there's another one where the green one starts, where the purple one starts, where that purple one starts, where the red one starts, purple starts, orange starts, and red starts. And these can all just be in a line. I just was being lazy with my diagramming. And then if I just use these as the initial seeds to search for, I've reduced my problem space from all of the things on the black line to just the orange lines. Yep. I think that'll work. I think, oh. Do we even need to optimize? Do we even need to optimize? No? How long did it take? Oh, 2 minutes? That's not even awful. Like, you know, I think we could consider that we got it solved. Brute force part 2. So there we go. That's why you use Rust. You can brute force a problem if you need to. Not sure that would have brute forced as easy in like Ruby or other languages that I'm used to. But let's see if we can do this a bit differently. So like from the maps, right? We have a entry for a map. Wait. What do I want? Because each map entry is a range, right? Yep. Okay. So for a map, we want to impl a function called range starts revert untranslated. No, reverse translated. Range, destination range starts reverse translated. Oof. That's a sentence. So this one doesn't take a seed. It just does this, and it returns a vec of starts. Yeah. So for the entries. So this just gives us the destination range start, but that doesn't give us the source mapped value, and I want the source mapped value. Wait, so it's just source range start, right? It's just the other one. It's just the source. It's just source range start. Well, that works at the bottom level, right? But then when oh yeah, okay, but then I need to ask the layer of, okay. Excalidraw again. So if we're at like this red layer, and I got the purple's source start, but then I need to convert it to my thing where it's then the destination. Oof. Source range starts. This isn't an exciting method right now. Let's look at this. Let's just go back to the problem. There we go. Okay. So if I have 90, if I have 56, right? That translates to 93. It like reverse translates to 93 because I want to go backwards. Yep. Destination start to source start. So if I'm trying to go back up the tree and convert 50, I can convert 56 to 93. And then in this one, I can convert 93 to 93 because nothing covers this one. Yeah. Oof, this is getting a little messy, but it's okay. I think I like this idea and I want to play with it and see if I was right. So this is going to be, I'm going to rename this to translate down. And I'm going to write one that's translate up. If seed is greater than the destination range start and less than that, yeah, it's exactly the same as this, but with source and destination flipped. Okay, so now we have a translate up. So we can do starting. So this is for one entry. Start translated up. It just takes self and it returns a U64. Where it's self let seed equals self dot destination range start, self translate up seed, unwrap or seed. Yep, because if there is no translation up, then you're fine. So start translation up now gives you the starts in one level above you. And now I need to be able to translate all of those up again and add anything that was below me, if there was one below me. Okay, so let's just write that as a method where we can important points. It takes maps, which is a slice of maps. Let mutable maps equal maps. Oh yeah, let's actually just take a vector reference. Oh, actually no, wait. Yeah, it's fine. We'll make this into a vector. Apps.reverse. Not apps, maps. Oh, clone has to be satisfied on map. That's okay. We can do that. And then let maps equals maps to make it unmutable. So map needs to also implement clone for this, which is easy. Oh, map entry then also needs to implement clone. They could even really be copy. It would be okay. Okay, so then we have our maps. Let mutable points for m in maps. Let translated points equal points.iter map. So this is on the points. No, map dot. Oh yeah. Map.entries, got it. Iter find map translate up. Got it. Yep. Find map. Filter. This can be a filter map. Collect to a vec. Do down here. Okay, so then this is translated points. Yep, vec of U64. Actually, no, I don't want that to be a filter map. I want it to be a map. Because this is translated up, unwrap, or P still. What? Find map. Oh, yeah. This was supposed to go outside of the find map. Found that, dereference it. There we go. Okay. Now this is a spec of U64s. Okay, perfect. So then let, so this is mutable translated points. No, sorry, I don't want to let. Translated points dot append. A mutable reference to let new. Wait, this is not a great. A naming is map dot entries dot iter map. Yep, start translated. It's not start. It wasn't called that. I called it start translated. Oh no, it is start translated up. Okay, cool, whatever. To new points. Yep. Oh, this can be collected. Can't bar. Oh, yep, that's fair. So then points equal translated points, because I want to switch it out every time and translate all the way up the stack. So then these important points is just points at the end of the day, once you've gone all the way through the reverse map. Okay, so let's see now if in part 2, part 2 seeds dot parse input. Okay, and then debug out input dot important points. Oh, important points is important points because I didn't write it like that. Input dot maps. Debug it. Debug. To do. Okay, awesome. Cargo run. Those look like some important points. Okay, so what if I then just run it with that important point? Oh, yeah, okay. Let t equals those. Doesn't even need to be a reference to it. It can just be the thing. So the points iter map value min. Yeah, that. Dang. Wouldn't that have been so cool if that just worked? I'll debug this for a minute or two, but then I might just give up and call it a day with what we already got. Yep, so these give lots of things, right? There's lots of points that it thinks are important. I didn't even take into account the seeds, like, at all. Like, those seed ranges, I just don't... Oh, so that's what I have to do? Important points, so... Okay. So input dot seeds. Yeah, okay, so important points dot iter dot filter for points where input dot seeds dot iter dot any. Yep. So now there's any seed where seed dot include contains p. I don't know if Copilot got all of those things right at the end there. Cool. Seeds dot entries, I think is what I called it again, just because I didn't have a better name for it. Yeah. Perfect. Yeah, no method contains. Generate this method. P is greater than seed start and less than seed start plus count. Yep, exactly. Found that. Okay, so double. Still found that. One more. Oh, okay. Let important points. Iter filter. Woohoo! Oh wow, is that the right answer? I did it! We optimized it. There we go. Awesome. Okay, so that was the optimization. We had to find the important points by going backwards up the map until we found things to care about. And then once we found the points that could matter, these transition points. Yeah, once we found... Okay, so the answer here was to go backwards from the lowest level map to find important points. So the only points that matter were the start of ranges at any level. So you had to find the starts... the starts of ranges from this first highest level map, or the bottom one in our input. And we had to translate in the opposite direction we were used to. So this point was important, and this point was important, but to go from the yellow to the green, we had to translate from the yellow number system to the green number system. So here, actually, let's do this. Here's how we can show. So I'm going to redo that explanation so I can chop it up later, potentially. So the key for a part 2 optimization was to work in the reverse order through our map. So working from, in my diagram, the top down, or from the bottom of our input file towards the top. So the points that matter are the transition points. So there's a point that matters here in the orange. Oops, I didn't want to, there we go. There's a point that matters there in the orange. And then we had to translate that to the green color. So there's another point that's like the corresponding one, but translated to green. And then we also care about the start in the green. And then in the purple, we need this one that comes down from there. Oh, whoa. We also care about the start of this one, start of this one, start of this one, and then this translated one again. And then finally, we'll do at least the reds just to finish it off. Probably one of those, make it red. We care about that point. We care about the translated one, translated one, start of that one, translated one, start of that one. So then these ones really can, you have no more translation left really, and you can just drag all these down and care about them. And then actually something that's kind of important is that if the black is our seed, if there's another map like out here, maybe we counted the important point for it because it's where there was a border, but we don't bring it down to this last level because it's not a seed value. That was the important bit that I missed right away, is that for the important points, you only want to count one that is contained in a seed entry. But after that, we were able to solve this, and it only takes like milliseconds now. So we went from it taking about 2.5 minutes in Rust release mode to about 600 milliseconds. So I think that is gonna finish us off. So let's make a commit here. Part 2 optimization. Awesome. Okay, let's push that up. And with that, I think I'm going to get out of here for the day. Thank you so much for hanging out with me for part 5 of Advent of Code, and catch me tomorrow for part 6. Thanks, team. See you later. Bye.